Introduction. What is nickel phosphorus coating? Electroless nickel phosphorus (NiP) coatings help protect carbon steel from rust and wear, especially in harsh environments. They coat evenly, even on complex parts. Low phosphorus coatings are harder, while high phosphorus ones resist corrosion better. These coatings stick well and have low porosity, making them durable. Still, chemicals like chloride and CO can cause damage over time. Understanding how these coatings behave helps improve them for different industrial uses. What is the problem statement? Carbon steel is widely used because it's strong and affordable, but it rusts easily in environments with chloride and CO. Electroless nickel phosphorus (NiP) coatings help protect it, but most research focuses on general methods. More work is needed to improve the coating process, especially for harsh, high-temperature conditions. Electroless nickel phosphorus (NiP) coatings have shown strong potential for corrosion resistance. However, most existing studies focus on general deposition methods, with limited attention given to optimizing key parameters such as phosphorus content, bath conditions, and post-treatment processes. There is a clear research gap in developing optimized NiP coatings specifically tailored for carbon steel, particularly for use in highly corrosive environments. What is the objective? First objective is to fabricate the NiP electroless coating on carbon steel with 196 μm. Second is to determine the optimized parameters for NiP electroless. Lastly, to evaluate the effect of NiP on harsh corrosion environment. What is the scope of study? Measure the effectiveness of NiP coating reaction in HCl solution. For the equipment, we will use beaker, weight scale, spatula, PPE, water bath machine. For the substrates is carbon steel. Lastly, coating composition are ammonium chloride, sodium phosphate, monohydrate, nickel, 2-sulfate, trisodium citrate dihydrate. What is the literature review? Corrosion resistance of NiP coatings. Electroless nickel phosphorus (NiP) coatings, especially those with high phosphorus content, significantly enhance the corrosion resistance of carbon steel through the formation of protective amorphous layers. Performance evaluation through standard tests. The effectiveness of NiP coatings is assessed using standardized corrosion tests such as salt spray, ASTM-B117, immersion, ASTM-G31, and electrochemical techniques like EIS and potentiodynamic polarization. This study employs weight change measurements to optimize NiP coating parameters for corrosion resistance, while future research will focus on developing composite, hybrid coatings, conducting long-term industrial performance studies, and using advanced characterization techniques to create data-driven, durable coatings for aggressive environments. What is the methodology? The method used to evaluate the durability of the NiP coating in room temperature by immerse the substrates that have been coated into 37% of hydrochloric acid, HCl. One of the key testing method employed in this experiment is immersion testing at room temperature. Electroless coating. The method used to coat the surface of the substrates using ammonium chloride, sodium propionate, monohydrate, nickel, 2-sulfate, and trisodium citrate dihydrate. This method's called electroless coating. It is used to prevent the substrates from corroded. This is the procedure for the experiment. First is weight all the composition. Second is dilute all the composition in 40 ml water. Third is weight the mass of the substrates before coating. Fourth is insert the substrates into the diluted composition. Fifth is take the substrates and composition into the beaker and place it in water bath machine. Sixth is take out the substrates after 60 minutes. Seventh is weight the substrates mass after coating. This test is done to test durability of the coating and the substrates. The microstructure of the carbon steel after indentation. Sample numbers 1 having the great hardness of coating compared to another samples. This can be determined because of the value of Vickers hardness, HV, average of 3 time of indentation value which is 397.06 HV, and the lowest hardness of coating is sample 4 with the value only 132.57 HV. Testing method. Coated samples are fully immersed in 37% HCl at a room temperature. The weight loss, mass loss, is measured over time which is from day 1 to day 6. Inspect the microstructure of the substrates after immersion using SEM machine. Scanning electron microscopes, SEM, microstructure before and after corrosion. This is microstructure of sample 2, with parameter 6 days of immersion. This is microstructure of sample 3, with parameter 6 days of immersion. This is microstructure of sample 5, with parameter 6 days of immersion. This is microstructure of sample 6, with parameter 6 days of immersion. Most of the distribution of pitting corrosion is on uncoated sample microstructure after 6 days of immersion. This result shows that how important to coat the substrates to preventing corrosion. Weight gain and lost. The chart shows the weight loss of 9 samples after being tested through immersion. Each sample started with a similar actual weight of around 45.6 grams. After testing, each sample experienced weight loss in 6 different stages. Sample 1 had the highest weight loss overall, while sample 3 showed the least. Most samples showed fairly steady and consistent weight loss across the stages, suggesting a uniform effect of the immersion process. The visual clearly highlights the difference between the original weight and the reduced weights after each test, indicating material degradation or absorption effects. Market potential. Market potential. Firstly, widely used material. Carbon steel is used everywhere from buildings to cars, but it rusts easily. Next, better protection. The NEP coating helps protect steel from rust, especially in harsh environments. Furthermore, high demand. Many industries, like oil, construction, and marine, need better ways to prevent corrosion. Lastly, cost-effective. This coating is affordable, energy efficient, and works well on complex parts. Social benefit. Social benefit. Make safer infrastructure. Longer-lasting steel means safer bridges, buildings, and machines. Another that, less waste. Extending steel life reduces the need for replacements, saving resources and protecting the environment. Lastly, lower costs. Companies and governments save money on repairs and maintenance. Was the experiment successful? Indeed, in this study we have successfully proved NEP coatings as a cost-effective solution for carbon steel protection, delivered optimized parameters for real-world applications, and advanced the understanding of corrosion mechanisms in coated systems.